So the stuff we've done already, yeah, I'm starting the video a little bit late, but the stuff that we've done already isn't as relevant as the stuff that I'm going to do, because mostly what you need to see is examples and how we use these identities to solve our examples. So if we let theta be like some acute angle, be an acute angle, let theta be an acute angle. Acute means less than 90 degrees, right? Excuse me, such that it's going to be a good video of me like hacking away, such that sine of theta equals 0.6. It's written really tiny. So we want to find the value of cosine of theta and tangent of theta. So we have one piece of information, right? We know what sine of theta equals. So we can look at this, and let's start with cosine, right? We want to find the cosine of theta first. So I'm going to go, okay, what do I know about sine and cosine? Like, do any of these work where they're just sine and cosine equal to something? So if I look up here, I don't have anything that works with sine and cosine in the same equation, right? We've got sine equals 1 over cosecant, cosine equals 1 over secant. So nothing in here is sine with cosine, right? But here I have something that is sine and cosine. Now down here I have a sine and cosine, but it also has a tangent. And so we'd have to know at least 2 of those 3 things to be able to solve it. But up here I have sine squared of theta plus cosine squared of theta equals 1. So to find cosine, I'm going to use this identity right here. Why? Because I have a value for sine of theta, not sine squared of theta, but sine of theta. So to find my cosine of theta, I am going to use sine squared of theta plus cosine squared of theta equals 1. Well, we know what the sine is, right? Sine is 0.06. So I can say that's, 0.6. So I can say 0.6 squared plus cosine squared of theta equals 1. Can I? Is there any reason I can't do that? No worries, Desiree. So you're going to need a calculator for some of this, because a lot of you aren't going to know what 0.6 squared equals, right? But what do we know first? We can get this isolated. We can subtract this 0.6 squared from both sides, right? Minus 0.6 squared. And I'm going to get cosine squared of theta equals 1 minus 0.6 squared. Well, I believe that that would equal 1 minus 0.36. Am I correct on that? 0.6 squared, 0.6 times 0.6 equals, yeah, 0.36. right? And when I do the math on that, 1 minus 0.36 is going to be 0.64. So right now what I'm looking at is the cosine squared of theta equals 0.64. But we're not trying to figure out what cosine squared is, right? We're trying to figure out what cosine is. How would I find what cosine is from cosine squared?
I'll be honest, missing those days of class did a number on me.
Well, this takes you back to algebra. How do you find the value of x when you have x squared? If I have x squared equals 64, how would I find x? Um, Close, but no on the divide. So if I have x squared equals 64, maybe it'll help to see it instead of just having me say it. How would I find the value of x? If I have something squared, we would take the square root of both sides, right? This would give me x equals plus or minus 8, correct? We don't really have to deal with the minuses in this realm because it's definitely going to be positive, right? Because it's between 0 and 90. So if I take the square root of this and the square root of this, I get cosine of theta equals 0.8, right? Just like if it was an x value, if I want to find the square root of something, I just square both sides, take the square root of both sides, right? If I have cosine squared of anything or sine squared of anything, and I want to find what sine is or cosine is, I just take the square root of both sides and it takes me out of it. That's why I said it was close when you said divide, Moises, because I know everybody confuses this and this, the division symbol, and then the radical. So we know that this is 0.8. So what do we know? We started with sine of theta equals 0.6. And we have cosine of theta equals 0.8. We also need to find tangent of theta. And so what do we have that has tangent, sine, and cosine in it? Or tangent and cosine, or because I have values for sine and cosine, and tangent equals sine over cosine, right? Right here, tangent equals sine over cosine. So we could just write this as 0.6 over 0.8. And when we reduce that fraction, we would have equals 0.3 over 4 or 0.75. Yeah, so we would have 0.3 over 0.4, which is 0.75 if we were to put it in a calculator. Does that make some sense? So tangent was kind of easy, right? I should put like a line here so we could tell that we're dividing that now. That's not the same problem, right? So once we had sine and cosine, it'd be really easy because we had those two values already. But does that make a little bit of sense? I'm going to do another one that's like that. uh, just for funsies. Um, and we'll bring this down with us. Come with us. So if I have the same type of problem,
Oh, I grabbed the wrong one.
Did you see that? I need to like grab it as a whole. There we go. So say I have the same kind of problem. I haven't worked this one out yet. So say we have a cosine of theta that equals 0.96. 0.96. And what we want to find is sine of theta and tangent of theta. Sine of theta, tangent of theta. So if we were like going to draw that, right, on a triangle, right? So I have this triangle, and this is our, ooh, see how pretty that made that? And we're going to say that this is our theta, right? We know that cosine of theta is 0.96, right? That's all we know. So far, right? What do I know about that? I know that sine equals, well, here I have cosine. I want to find sine. I think we can use that same Pythagorean identity, right? Last time we had sine and not cosine. This time we have cosine and not sine. But that Pythagorean identity will still work for it, right? We're just going to have to find the opposite, right? Now, this time we're looking for sine. But we can still use that. You will use this Pythagorean identity a lot. So really get used to this one. Sine squared of theta plus cosine squared of theta equals 1. So if I use that, right, if I have my sine squared theta plus cosine squared of theta equals 1, just where cosine is, we're going to put in 0.96. So we could say sine squared of theta plus 0.96 squared equals 1. And then when we solve that, all we have to do, we can start by moving this 0.96 over. So we have 0.96 squared minus 0.96 squared. And we're going to be left with this sine squared of theta equals 1 minus 0.96 squared. Now, I don't for the life of me know what 0.96 squared is, but I have a calculator. I haven't solved this problem out yet. I just, so if I go 0.96 squared, I get 0.9216. So I wind up with 1 minus 0.1 minus 0.9216. Well, once I have that, this part becomes easy, right? Because I just go 1 minus that. And ooh, that's an ugly number. And this becomes sine squared of theta equals 0.0784. And then to find the actual sine of theta, we just have to take the square root, right, of both of those. And so now I definitely need a calculator for this. I'm having issues. They're like old people issues now. And that is that I wear glasses to see far away, but I don't need them for close up. And so this is going to equal 0.28. So our sine of theta equals 0.28. And in the book, I have the answers, but I don't have how to solve it. And I was right. It is 0.28. So we got that part right. So what do we do now to find tangent? Well, just like before, tangent is still sine over cosine, right? And we just happen to have both of those numbers right there, 0.28 over 0.96. I would just reduce that in your calculator. And we would get 0.291. We'll round it up to 7. Followed the exact same procedure, right? Nothing changed between how we solved those two problems. Sometimes you're going to be given all sorts of different things to work with, right? It's not always going to be a Pythagorean identity. Sometimes you're going to get, I'm going to try and move this without fully obscuring what we just
How'd
did.
you get the 0.9217 for the end of tangent?
The 0.92
17?
2917, 0.2917. I just divided 0.28 by 0.96.
Okay, that makes sense.
Yeah. That's all. Yeah. I just did the division on it. Anytime I have like a point anything in a fraction, I always just do the division because it's already a decimal. You might as well just keep it a decimal. What if I have, what if we let theta be an acute angle, right? I like the acute angles because it keeps everything between 0 and 90 degrees, right? Such that, I'm not used to writing such that. There's symbols for that in math. You don't usually write, after a while, you don't write such that anymore. Tangent of theta equals 1/3. That's what I mean, like I have to do that. Right? We want to find cotangent and secant of theta. Cotangent of theta and secant
Is
of theta.
that top one L-E-T or L-A-T?
It's let the words let theta. Let theta be an acute angle. I didn't even write the word angle. Angle such that tangent of theta equals 1/3. And we want to find cotangent and secant of theta. So we have tangent. We know what tangent is, and we want to find cotangent, right? Well, if I look at my identities here, I can go, well, tangent just equals 1 over cotangent. And cotangent equals 1 over tangent, right? So what do I know? I know that cotangent of theta equals 1 over tangent of theta. And we know what tangent of theta equals, right? It equals 1/3. So can't I just say then that this is 1 over 1/3? Can I use those interchangeably? We know that tangent equals 1/3, and we know that cotangent equals 1 over tangent. And so I can just, wherever the tangent is, I can put in 1/3. Now to solve this, if you remember, if you have a fraction over a fraction, you just multiply by the reciprocal, right? So I have 1 times the reciprocal of 1/3, which is 3 over 1, which just equals 3. So cotangent just equals 3, right? So now we have two pieces of information. We have that cotangent equals 3, and we have that tangent equals 1/3, right? One was given to us, the other one not. Now it says we need to find secant, right? Well, what do I know about secant? If I look at all of these, I can go, okay, well, secant is 1 over cosine, but I don't have cosine, right? What else do I have that has secant and tangent? I mean, cotangent, secant, or tangent in it. Well, I have this one right here, right? It's got tangent and it's got secant. It's Pythagorean identity, right? I can't see any others that would work that have both of those things, right? I can do the one that's cotangent, but that has cosecant. It doesn't have secant. The only thing that has two of the things that I have information about or need information about is that 1 plus tangent squared theta equals,
And this is for.
we got to find the secant of theta, right? We know what the cotangent is. We found it. I don't see any way to use it to help us. I think the only thing that we have that we can use to find it is the one that has tangent and secant in it. So equals secant squared of theta. And so what do we know? We know that tangent is 1/3, right? So I can go 1 plus 1/3 squared equals secant squared of theta, right? So that gives me 1 plus 1/9, right? 1/3 squared is 1/9 equals secant squared theta. I need a common denominator here. That denominator is going to be 9. So I could say 9 over 9, which is the same as 1, right? 9 over 9 is 1. Plus 1/9 equals secant squared theta. That's going to give me what? 10/9 equals secant squared theta. So we know now what secant squared of theta is. The only thing we need to do now is take the square root of both sides, right? If I take the square root of this and the square root of this, I get radical 10 doesn't reduce, but 9 is a perfect square. So it'd be radical 10 over 3 equals secant of theta. Right? So we know up here that secant equals radical 10 over 3. And so we found both those things that we were looking for. I think I'll do another one like that. And for the other examples, I will just make a video of those. I think I might stop after this next piece. I was going to get into the wordy problems a little bit, but maybe we will start off on Monday like this. This is getting to be kind of a lot of information, right? And so I think what I'll do is I will do one more quick example of the type of problem we just did. And then the next example I will save for video for you guys to look at. And then we will get into more of the application word problems the next time I see you. And we'll just make this a 3-part section instead of trying to jam it all into 2 parts, which means that your homework is about to get significantly shorter. So let me bring this down with me. Doesn't want to move. Even it's tired of this lesson. You know what we really need to shake things up? We need another color. We need me to stop writing in blue. Even though blue is my favorite color, it matches my eyes. I feel like even this lesson's ready to give up. It doesn't even want to like move my identities anymore. I think everything will be better in orange. So let's say that we know that tangent is equal to 2. Tangent of theta equals 2, right? What do we want to find? We want to find cotangent of theta and secant of theta. So once we know tangent, we know that tangent of theta equals 1 over cotangent of theta, right? Just like we did before. But we know what tangent is, right? We can also say that cotangent of theta equals 1 over tangent of theta. I like this one better. Both will work, but I like this one better because it requires less moving stuff around, right? Because if I put in that this was 2 equals 1 over cotangent, then we would have to, well, we'd have to multiply everything by cotangent, blah, blah, blah. This to me makes the math simpler because I could just write this as 1 over 2. Well, look at that. That's just 1/2. Cotangent's done, right? What about secant? Well, again, we're going to have to use that Pythagorean identity, right? We've got 1 plus tangent of theta, tangent squared of theta equals secant squared theta. But what do we know? We know that that tangent is just 2. So that's saying 1 plus 2 squared equals secant squared of theta. So that's 1 plus 4 equals secant squared of theta, which is 5 equals secant squared of theta. So the only way to find out what secant is to take the square root of both sides. So I'm going to take the square root of this side and the square root of this side. And I'm going to wind up with the square root of 5 equals secant of theta. Can't be reduced, right? I'm going to leave it at that for you guys. I'm going to leave this up so you guys can finish taking notes on it. I'm going to do like 2 more examples in another video before the end of today. Now that I know where I'm stopping with you guys, I will make sure and have your homework posted by lunch today. Hopefully sooner than that, but definitely by then. My tutoring hour is the last period of the day, so at 2:05. Fridays I can make a little bit more. I have prep 3rd period, so if you need a little extra help and you want to come in.
It's just one of the homework assignments, which is 4.1.3. That rotation one.
4.1.3 was that like the word problems?
Yeah, find the angular speed and rate.
Yeah.
Yeah.
Come in here today if you have time. Come in today and we can get that done.
Okay.
Yeah.
Just because my grade is 77 right now.
Everybody had trouble with the word problems.
Oh my
You
God.
too, Cyan? Well, my tutoring hour is at 2:05. So if anybody wants to come in and work on that, let me know. I'll just open up the meet so that you guys